All right, you're going to want to stick around for this because what we're about to get into sounds like it's pulled straight from science fiction. I want you to imagine generating real, usable power, not from some massive power plant, but from a jar of warm salt water and a magnet. I know, it sounds impossible, but according to some really fascinating research, it might just be where we're headed. You know, the hunt for clean, efficient energy is pretty much one of the biggest challenges of our time. And the researchers behind this paper, well, they put it perfectly. The absolute holy grail is converting thermal energy into mechanical energy with efficiencies exceeding 80%. It's the ultimate prize, and they think they've stumbled onto a major clue. I mean, just think about that for a second, that this enormous global challenge could have a solution hiding in something so incredibly common, so simple, so everywhere. That's the wild claim we're going to unpack right now. So let's get into it. What is this radical claim exactly? Well, it's not about a new kind of fuel or a slightly better solar panel. No, this is a completely different way of thinking about energy, and it all starts at the atomic level. So the core idea here isn't about burning anything or using complicated turbines. It's about tapping into a fundamental property of matter itself. The theory is that we can actually harness the tiny, hidden magnetic forces inside atoms and get them all working together for us on a huge scale. Okay, to really wrap your head around this, we have to zoom in, like way, way in, because at the very heart of this whole concept is this weird little property of atoms, a tiny wobble that holds the key to everything. It all kicks off with something called a magnetic moment. Basically, some atomic nuclei, the very center of atoms, act like microscopic spinning compass needles. Each one has its own little north and south pole. And this isn't some rare exotic thing. It's a basic property of tons of common elements. Now, here's where it gets really cool. When you stick these little atomic magnets into a bigger magnetic field, they don't just snap into line like a regular compass. Nope. Instead, they start to precess. And the best way to picture this is to think about the wobble of a spinning top just before it falls over. That little wobble, that's the secret sauce. And get this, you can actually manipulate that wobble. If you zap these wobbling nuclei with just the right pulse of energy, like a radio frequency wave, you can literally knock them into a wider wobble. This pushes the nucleus into a higher energy state. It's kind of the same basic principle used in MRI machines, but here the goal is totally different. It's about generating power. Okay, so that's the theory on a super tiny scale. But how in the world does that translate into a real experiment you can actually see? Well, the researchers started by zapping a specific metal called bismuth. And this is where things get really exciting. This is the million-dollar question, right? I mean, it's one thing to mess with a single atom's wobble, but can you actually get trillions and trillions of them to sync up and produce enough force to move a physical object? To test this, the team put together a really clean, simple experiment. They took a disk made of bismuth, which is a material whose atoms have just the right magnetic properties, and they popped it right between two powerful magnets, a super direct setup to test the idea. And the result? It was absolutely groundbreaking. They zapped the disk with that RF pulse at just the right frequency, and once they cranked the power past a certain point, boom, the disk physically started to turn. This was it. Proof that invisible electromagnetic energy could be converted directly into visible mechanical work just by getting the atomic wobbles to sync up. That first experiment was a huge proof of concept, a major win. But the next step, the next question is even bigger. Can you get the same result without a targeted energy beam? Could you do it with just heat? The theory goes that heat, which is really just random atomic vibration, contains a whole mess of frequencies. So could the atoms themselves pick out the exact frequency they need from all that thermal noise to get their wobbles in sync? And this is the device they built to find out. It's a prototype designed for one specific purpose: to see if plain old thermal energy, the random jiggling of atoms we call heat, could be harnessed to create that same synchronized motion. The setup is really clever. You've got this outer guide disk holding the magnets, and that gets spun by a motor. But the part we care about is the inner cylinder. It's made of titanium, and it's completely free to spin on its own. So the question is, if you spin the outer magnets, will that inner titanium cylinder decide to follow along with absolutely no physical connection between them? What they observed in this experiment was just stunning. Below 30 degrees Celsius, nothing. The cylinder just sat there. But once the device warmed up past that magic number, the inner titanium cylinder started to rotate. But here's the kicker, the absolute most important part. As it was spinning, its temperature dropped. It actually got colder than the room it was in. Just let that sink in. The energy to make it move had to come from somewhere, right? That temperature drop was the smoking gun. The device was literally pulling thermal energy out of the titanium itself, eating heat from its surroundings and converting it directly into motion. I mean, this is an incredible breakthrough in the lab. But now let's zoom back out and connect this to the real world and back to that initial promise of saltwater. Because it turns out that saltwater is absolutely jam-packed with atoms that have this exact magnetic property. We're talking sodium, chlorine, and, of course, the hydrogen in the water itself. The researchers confirmed it. The same principles work. You can harness that atomic wobble in a liquid, too. And the potential here is just staggering. The paper points out that a single cubic meter of seawater holds about 1 kilowatt-hour of latent thermal energy for every single degree Celsius of its temperature. Our oceans are basically a massive, untapped battery of low-grade heat. And here is the immediate, world-changing application. Desalination plants, the ones that make fresh water from the sea, use a ton of energy. This technology could potentially use the warm, salty wastewater from the plant to help power the plant itself. It could create a sustainable cycle that helps solve our water and energy problems at the very same time. And if all of that wasn't mind-bending enough, to cap it all off, the researchers describe one final demonstration that is so simple, it makes this phenomenal science feel almost tangible. They actually show how you can see this effect for yourself using basically just some simple glassware. No complex lab equipment needed, just a container of salt water and a strong magnet. The steps are just wild. You take some warm salt water, you stir the outside with a strong magnet a few times to get those atomic nuclei wobbling, and then you just take the magnet away completely. You wait a few seconds for the atoms to sync up on their own, and then, impossibly, the water begins to rotate, all by itself, powered only by its own internal heat. As the paper itself says, it's amazing. So it really leaves you wondering, doesn't it? After a century of building these massive, complex machines, could the next great energy revolution be this elegant, this fundamental? Just tapping into the atomic dance that's happening all around us, all the time, just waiting for someone to lead.